All right, so next we're going to talk about synapse.
I apologize.
Sure, you
Tardiness.
do. You have one for you. How about that, Rhonda? What do you have to say now?
When you're wrong, the best thing to do is to just agree.
Exactly, right?
Yes.
So you're saying that I'm wrong or you're wrong?
I'm saying you're right.
I like that. I had your lab.
Oh, I'm scared to look at it.
Oh,
You guys looked at yours?
Well, then you don't have to look at it.
No, I need to look at it.
No, look at it.
Oh.
No. You should be scared.
Oh, yes. No. Close.
She made a.
I made a 98.
Okay.
Yeah.
Good job.
Okay. All right, so we're talking about the synapse next. And so basically, like we mentioned before, when neurons function, when they form and transmit, when they create an impulse and then they have to transmit it over, it happens through the means of a synapse. And that's a very similar concept, just like when we talk about the neuromuscular junction. You guys remember that, right? Please say you do. Okay, neuromuscular junction, what is that? Neuromuscular junction. You don't have to say the exact definition, but at least give me an idea. What does it make you think of when I say neuromuscular junction? Connection between what and what? Muscle and neuron, exactly. So in order for your muscle to contract, it has to be innervated by a neuron. So we did draw something like, this, right? Remember that? This is the axon ending and the membrane, okay, of the muscle fiber. So that is the same concept, okay, that applies when it comes to the synapse. The only difference is that right now we're not going to talk about the muscle fiber and neuron, but we talk about neuron and neuron, okay? So that's how the impulse is being transmitted throughout your nervous system from neuron to neuron by the means of synapse. So right here on the synapse, the junction between two neurons where the nerve impulse is transmitted. Okay, so the junction between two neurons where the nerve impulse is transmitted. Okay, so basically, again, we have a neuron, we have another neuron, so this second one could be, the body of the neuron involved, or it could be, what are these? Dendrites, okay? And so then the impulse, travels from this presynaptic neuron onto this second or postsynaptic neuron. Now what we're going to focus on right now is we're going to pay attention. This can be very confusing. It is physiology. If you miss it, you miss it, okay? So basically we're going to take this part of the postsynaptic neuron and understand from a chemical standpoint what exactly happens there, okay? And how can this neuron form an impulse? What type of chemistry happens at this level? And you remember how I told you the nerve impulse travels throughout the nervous system, just like the electricity travels through the wire. Now the question is, how can that happen? What type of chemical, or what type of electrical charges or changes take place at this level in order for the impulse to be able to excite, this postsynaptic neuron? So this will be the concept of right now cell membrane potential. So before we get to talk about how the the nerve impulse is being created, we have to understand what a cell membrane potential really is. Okay? And I want you guys to write down, I'm going to dictate a few principles and we're going to explain them. Okay, so some principles before we get to that. All right, so principle number one, write down. At rest, so number one, at rest, a neuron's cell membrane, so at rest, a neuron cell's membrane is polarized or electrically charged. So at rest, a neuron cell's membrane is polarized or electrically charged. Okay? Again, nothing to understand yet. Okay? This is what it is. Okay? We just know that when a neuron is at rest, so before it gets excited, okay, we know the membrane, okay, of the neuron is polarized or electrically charged. Number two, this polarization, so the polarization is caused by what we call a potential difference, which we call resting potential. Okay, so the polarization is caused by a potential difference, and that potential difference is called a resting potential. The resting potential. Number three, the resting potential is given by unequal distribution of ions on the inside and outside of the cell membrane. Okay, so unequal distribution of ions on the inside and outside of the cell membrane. Number four, the unequal distribution of ions, bless you, the unequal distribution of ion is caused by remember what this is? It's caused by the sodium-potassium pump. Okay, so the unequal distribution of ions is caused by the sodium-potassium pump. Who remember the sodium-potassium pump? It's a form of transportation across the cell membrane. It is the only active transporter we mentioned. Okay, when you guys learn that. Number five. Sodium-potassium pump moves ions inside and outside the cell membrane. Okay? So the sodium-potassium pump moves ions inside and outside the cell membrane. So when I say the sodium potassium pump moves ions inside and outside, which ions does the sodium potassium pump move? Which ions do you think it moves inside and out? It is called sodium potassium pump. So what type of ions? Sodium and? Thank you. You guys awake? And so the way it moves these ions, okay, is this. It moves 3 sodium ions out, and it brings in 2 potassium ions in. Okay. So for every 3 sodium ions out, it brings in 2 potassium ions. Okay, number 6. Write down this action. So this action causes the cell membrane to be negatively charged. And this negative charge we are going to call the actual resting membrane potential. And there is an actual value of that, which is minus 70 millivolts. Resting membrane potential, which is minus 70 millivolts. All right, everybody get up. All right, go ahead and spin around a little bit. Spin, spin, spin. One way, good, the other way. Okay, stretch. Okay, down. Everybody awake? Sit down. Okay. All right, and everybody pay attention now, because if you don't get this, you're going to mess up with the next information. This is a chain reaction. I need your attention, and I need you to be awake. Okay, I know it's early in the morning, it's summer, it's hot, you don't want to be here, but you have to be here, you have to learn, and you have to pass this class, right?
Yes.
Good. So, we are talking about the synapse. Specifically, we're taking this at the cellular level to understand what exactly happens with the cell membrane when a neuron is getting excited or when a neuron receives a nerve impulse. Okay? So the way it's going to even happen is because the cell membrane is said to be electrically charged. Okay? When at rest, if you want to measure the electricity of the neuron cell membrane, you can actually apply this device and you can measure it, and it comes to minus 70 millivolts. Now we have to understand why do we have this value and how can this value actually happen. Good? So all of these steps, all of these principles pretty much explain to you how do you get to this number. Okay? That's what we want to understand. Why is the electricity of the neuron cell membrane minus 70 millivolts? So basically, okay, fact, at rest, the cell membrane is polarized. Good? Okay? Fact. This polarization, we're going to call, has a name. It has a name. Potential difference or resting potential. That is the fancy terminology. Okay? That pretty much tells you that when at rest, the cell membrane is polarized. Okay? Now, why do you have this potential difference? This is not a fact anymore. You have to understand this. Okay? this resting potential is given by unequal distribution of ions, okay, on each side of the cell membrane, on the inside or outside. If we have the same amount of ions on the inside as we have on the outside, we will not have a potential difference. We will not have an equal distribution, okay, of ions, and the membrane will be neutral. If a membrane is neutral, if a membrane doesn't have a charge, a neutral membrane doesn't do anything. It cannot cause any type of reaction from there on, okay? So again, this resting potential is given by unequal distribution of ions. Now you have to know which ions, okay, or what is the main mechanism that will cause this unequal distribution of ions. So the main factor, not the only one, but the big one, okay, the big mechanism is the actual sodium-potassium pump, which we know, the name pretty much tells you what it does. It's called sodium-potassium pump. It pumps, or it moves, ions in and out of the cell membrane. Clear so far? Okay, now how does it move it? This is the trick. Okay, this sodium-potassium pump is not a totally fair pump. Okay, look what it does. It takes out 3 sodiums, okay, and because of that, we're going to say that the major ion, so the major extracellular ion is sodium, okay, because the pump moves the sodium out. Okay, so if it's outside of the cell, we're going to call it what? Extracellular. Okay? So it takes 3 sodiums out, but it brings in potassiums, and that's why we say that potassium is the major intracellular, right? Inside the cell. Okay? Intracellular, extracellular. Now, I'm coming back to the unfairness of the sodium-potassium pump. Again, it takes out 3 sodiums, but it brings in how many potassiums? 2. If you remember when we talked about sodium and potassium, if we were to go back to the first or second chapter of chemistry, if we want to find out what type of ions, how many types of ions can we have? Who remembers? I'm telling you 2. You can have positive and negative ions, okay? And so both of these ions are positive ions, okay? Sodium is positive, potassium is positive, okay? So they're both positive ions. So now the question is, okay, if you take 3 sodium out, so you take 3 plus charges out, but you only bring 2 positive charges in, okay, you will constantly have a deficit of positive charges on the inside. You see that? For every 3 pluses that you lose, you only bring in 2 pluses. Okay? Just like if you have $10 in a bank, so let's use some numbers. You have $3 in a bank. Sorry, you have $2. Okay. Anyway, you don't have $8 in a bank. Okay. If you only have $2 in your bank, but you spend $3, what will happen to your bank account?
Negative
It
1.
goes into negative.
Well, negative 36.
Okay, whatever, right?
Yeah.
And so that's exactly what happens here. Okay, you are spending 3 sodiums, okay, 3 pluses, okay, but you only have 2 pluses. So you constantly have a deficit on the inside of the cell membrane. Does it make sense to you guys how this happens?
Yes.
Okay, so that's why we say that at rest, the cell membrane is negatively charged. Okay, the term for this one is the resting membrane potential, and the actual value is minus $70. The actual value is minus 70 millivolts. Okay, does it make sense? You got it?
I'm just a little bit confused between if it's polarized and it's doing the same thing. The reason why it's polarized is because there's an unequal distribution.
Exactly. Yes.
That it's also called polarized and resting membrane
the same meaning, different terminology.
Gotcha.
Okay? So this is what happens at rest. So I begin with a -70. When a neuron is resting and there is no nerve impulse, you're going to have -70 millivolts in there. Good? Now, we're going to take this a step further. Remember what I said. Okay, you have to understand this to understand the next concept. Okay. So now you want to understand what happens when the cell membrane is not resting anymore, but it actually receives a nerve impulse. Okay? So back here, okay, you have this presynaptic neuron, you have the secondary neuron, the postsynaptic. So now this neuron is resting currently, but not for too long. You get the action potential, so the excitation for the presynaptic neuron reaches the membrane, and the membrane now knows, uh-oh, I cannot rest anymore, so this -70 value is going to have to change. Okay? So in order to understand how this happens, you have to have a chart, a graph, so to speak. Okay, so you start here with -70 millivolts. Here somewhere is 0 millivolts. And up here somewhere would be the +25 or +30 millivolts. Okay, so again, we start with -70 millivolts. Again, what is this value standing for? What do we call this? Resting membrane potential. Okay. So we start here. Now, how many of you kind of vaguely remember the term of voltage-gated ion channels? We mentioned them before, okay? Voltage-gated ion channels. When we talked about the cell membrane and we talked about all of those proteins, integral proteins, peripheral proteins and such, I said that the integral proteins function, the main function is to be ion channels, okay? So they function as channels that allow for ions to go in and out of the cell membrane. When I said that a channel is voltage gated, what that means is a specific voltage can either open or close a particular channel, okay? Those channels are very sensitive to voltage and to changes in that type of voltage. So at -70 millivolts, what happens, and again, we are in the cell membrane, okay? -70 millivolts, okay, we have sodium channels open. Okay? Sodium channels open at -70 millivolts. Okay? Now I'm going to come back here for you to understand what happens next. Okay? What do we say the sodium? Where do we have a lot of sodium ions? Outside or inside the cell membrane?
Outside.
Okay, so we have a lot of sodium outside, okay, and we always have a little bit of sodium inside, okay, but not a lot. Okay, we have a lot of it outside and very little inside. Now, if I open this channel for sodium ions, I know that sodium cannot pass through the membrane. Remember, the membrane is selectively permeable. If I don't have an opening for the sodium, it will not be able to go anywhere. So now at -70, the channel for sodium opens, and you tell me now, according to the law of diffusion, which way will sodium travel, inside or outside of the cell membrane? Diffusion. High to low, so tell me, where does sodium go, inside or outside?
It's gonna go inside.
Okay, why does it go inside?
Because it's more outside.
Right. You have more outside than you have inside, and diffusion always moves molecules from the higher concentration to lower concentration. So at minus 70 millivolts, I have a lot of sodium moving inside the cell membrane. Okay, good. Again, what do we say about sodium? What type of ion is sodium? It's a matter of positive or negative. Come on, you have to think. Positive, okay? So if I have an open channel for a positive ions, I'm going to bring positive charges inside the cell membrane, right? If I bring positive charges into the cell membrane, what happens to the electricity of the cell membrane? Does it become more positive or more negative?
More positive.
Thank you, okay? So again, I begin with minus 70. My sodium channel's open. I have entry of sodium ions, which are positive ions, into the cell membrane. So because I bring pluses into the cell membrane, the electricity of my membrane becomes more positive. So I'm going to show it this way. Okay? So my sodium ions enter the cell. As I bring in the pluses, my minus 70, it becomes minus 60, minus 50, minus 30, minus 5, 0, plus 10, plus 20, plus 25 or 30. Good so far? Okay?
No, at minus 70, they're already unequal, right?
Yes.
So if we're putting more positive on the inside, wouldn't they still remain unequal?
Well, no, because the number is different. One is 3 and the other one is 2, so it's still being equal.
It's still unequal. But it's unequal in a different way, so it becomes more positive.
Okay,
Still unequal, but it's more positive.
okay.
So I'm bringing out, so let's go back to the analogy of, your bank account and your money. Okay, so you start with, minus $70 in a bank account, and you're going to start pouring some cash in there. Okay, so what happens to the bank account?
It's gonna increase.
Inside, you get more dollars in there, right?
Right,
It's still, it doesn't matter what number, but it goes up to plus.
okay.
Okay, and so we have, the thing here is sodium, we have enough sodium ions entering the cell membrane until we get to this number. Once I get to plus 25 and, or plus 30 millivolts, that is the trigger for these channels. Okay, when I reach this number, my sodium channels now I have to shut down, I have to close. Okay, so what happens here, two things happen. Sodium channels close and potassium channels open. Okay? So that number is a trigger for two mechanisms. Number one, sodium channels close, potassium channels open now. Okay? I'm going to show this in a different color. This is for potassium. Now once I close this channel, what happens to sodium?
Now it's trapped inside.
It's trapped, it stays there, it doesn't move in and out, nothing, okay? So once I close the channel, sodium doesn't move anymore. It's trapped, okay? However, once I open the potassium, what do I know about potassium? Where do I start with a lot of potassium? Inside or outside?
Inside.
Exactly, I have a lot of potassium inside. Where do I have just a little bit? Outside. So now I have an open channel for potassium. According to the law of diffusion,
Strong outside.
exactly, potassium will leave the cell. Okay, remember potassium is also what type of ion? Positive ion. So as I lose positive charges again, what happens to the membrane potential? It becomes what?
Less.
Decrease.
Decreases again. It goes down. I'm losing classes. Okay? And I'm going to get back to my resting, threshold, okay, minus 70. So here, potassium leaves. And I get once again to minus 70 millivolts. Once I get here, okay, plus 25 or 30 millivolts, this is where I can say that I reach an action potential. When my cell membrane, okay, when my cell membrane's value is plus 25, I know this neuron is firing, is sending that electrical signal. That is my action potential, or I'm gonna call it a nerve impulse. Okay, that's my value for the nerve impulse. Okay, so when they measure the electricity, if they record a plus 25, they know this neuron is activated right now. Okay, it's firing, okay, and it's conducting very nicely.
When it gets to the plus and out of the negative, is it still considered unequal? Or
Absolutely.
so it's always going to be.
It's still unequal. Okay, the ions, sodium versus potassium, will always be unequal. Okay, and that's why, I mean, if they were equal, okay, if they were equal, my value would be 0 at all times. If I had equal sodium as potassium, I would have a 0 value. They have to be unequal in order for me to have either a positive charge or a negative charge. Okay, good? Okay, so let's recap this. What do we know about a neuron cell membrane when the membrane is at rest? It's negatively charged. Okay, the value is minus 70. Okay, when I am at minus 70, what type of physiology happens at this value? What type of mechanism happens? Opening of the sodium channels. Okay, when I open the sodium channels, what happens to the sodium ions? The sodium ions move inside the cell. Why? Why? Because of the law of diffusion, which moves sodium from high concentration to low concentration, okay? So as I move sodium inside, what happens to the electricity at the cell membrane? Goes up because I bring in positive charges, right? How high can I go?
25 to 30.
Plus 25 plus 30, okay? And plus 25 plus 30, what type of mechanisms do I have? How many mechanisms do I have happening? 2. First is what? Sodium channels close, potassium channels open. What happens to sodium at this time? Doesn't move. What happens to potassium?
Moves out.
Goes outside. Why? Because of law of diffusion, which moves sodium from where? To lower concentration. What happens to the cell membrane? How low does it go again? Exactly.
Are you
Perfect.
done, Pop quizzes?
Yes. So, so
Thank you, Rolanda, for asking. You're welcome.
okay. Now, we have to learn the fancy terms for this phase and this phase of the action potential. As you can see, the action potential has two phases. Okay, there is an ascending phase. Okay, ascending phase, which goes upwards. It's ascending. And the way I call, so what I call this phase is against a logical thing, we're gonna call it the depolarizing phase. And the reason why I'm gonna call it depolarizing phase is because if you remember that one of the first principles that we discussed, we said at rest the membrane is polarized, right? The value for that polarization is minus 70, okay? So I begin from the polarized phase and I'm going to depolarize it. Okay, I'm depolarizing the phase. And the second phase, the descending, what do you think I call it? I'm going back to polarizing, but I'm gonna add the repolarizing phase. Yeah.
So when it goes down, to negative 70, then it goes to the resting potential?
That is the descending phase of the action
Right,
potential.
but it's also the resting potential, right?
Well, when I get here, so
Yes.
here is the resting potential.
Yes, that's all.
Yes.
Okay.
but all of this space still belongs to the action potential. So all of this, the movement itself of ions still belongs to the action potential.
Until it gets to the negative 70.
The negative 70 is the resting potential.
Okay.
Okay. Any other questions? Pretty straightforward. Now, if I just let you read this stuff in the textbook, would you make sense of it?
No.
Okay. You have to break it down. You have to break it down and understand it. If you don't understand, you can memorize stuff all day long, and I promise you're not gonna get it. Okay. So you have to. Besides the sodium potassium ions, there are a couple other ions involved in this mechanism, but it's not extremely relevant. So I want to make sure that you guys understand the big phases and the big mechanisms involved. Good. So now I want you guys to write down a couple more just principles or facts. Okay, we may want to call them facts about the action potential. Okay, number one, not all depolarization, so not all depolarization produces an action potential. The depolarization must reach what we call a threshold stimulus. The depolarization must reach a threshold stimulus. How many of you talked about pain threshold before? When I say I have a low or high pain threshold, what do I mean by that? If somebody has a high pain threshold,
They can withstand more pain.
they can withstand more pain. If I have a very low, pain threshold, you can just like touch me a little bit and I'm like, ouch, that hurts, you know? The same thing happens to this, okay? If, for example, so in other words, I have to have enough sodium entering the cell. If I don't have enough to reach the plus 25, if I only have like a couple of ions, I'm not gonna fire. So I have to have enough influx, of sodium in order for me to get into an action potential. That's what it means to have a threshold stimulus. Enough excitation in order for my neuron, to fire up to plus 25. Okay. Now there is a value for this minus 55 millivolts. Okay. That is the value for my threshold stimulus. So what that means is this. If my sodium, if I have enough sodium to fire up to minus 55, I will for sure reach my action potential. Okay? But I have to have enough sodium to cause this difference. Okay? From minus 70 to minus 55 in order for me to fire all the way up. So that's my threshold stimulus. The value for that is minus 55. All right. Another one that you have to know is the all or none response. There is an all or none response. It's almost like a law in physiology. So basically what that means is an action potential either happens completely, so an action potential either happens completely or it doesn't happen at all. Or it doesn't happen at all. It's just one of those things that, you're either pregnant or you're not. You can't be just a little bit pregnant, okay? The same thing with the action potential. If I say I'm gonna reach it, I'm gonna go up to 25 to 30, okay? I cannot just go up to 40 and be like, okay, well, I maybe did reach that, you know. You either do it or you're not gonna do it. And that's basically the odd or not response. Any questions about this? Okay, so this pretty much finishes the introduction of the nervous system. We are going to start talking about the central nervous system next. Let's take a 10 minutes off and we'll be back and talk about the spinal cord. And then we'll end, today we're gonna end the information that you have to know for the next lecture test, which will be a week from today.
Is our last class really the 24th?
I think so.
It's fast.
It is fast, we're almost there.
Yeah.
Okay. So basically, only have one more lecture test. What we cover in lecture after Wednesday, I have to look back on the dates and see if it's Monday or Wednesday your lecture test. I'm gonna give you the exact date when I come back. But what we cover past that, that information will still be on your final exam, so you still have to know it, because what we have on this next lecture test is what we cover so far in the spinal cord. The brain and nerves, okay, we're gonna cover after your lecture test, and the information will be on the final. Okay, if you didn't, if you're not here when I give you the test back, let
Can I
me
look
know.
at mine again so I can see
Yeah,
what
sure.
I'm missing? What about the lab test is gonna be a little bit more?
No, it's gonna be the